Hey there, ever wondered how scientists figure out the mysteries of the universe? How do scientists think? Well, it all comes down to a simple method called the scientific process. And you've probably used it without realizing it. Let's break it down using something you can relate to. Your car. And this is absolutely an experiment you can do yourself. Imagine you're driving your car and you notice that it seems to run smoother and get better gas mileage when you use premium fuel. That's an observation. It sparks your curiosity. Is premium fuel really better for my car? This is how most scientific discoveries start, an intriguing observation about the world. The discovery of special relativity happened because Albert Einstein, on the way home from work, noticed the town hall clock and wondered about riding a light particle. So you turned that observation into a question. Does using premium gas actually improve my car's fuel efficiency compared to regular? That's step 2, asking the right question. Galileo's experiments with motion started with the question, if I drop 2 different sized steel balls from a tower, will one land first? Have you dealt with a young child recently? Some of them are constantly asking why. Perhaps you were this child a long time ago. Hey, I've got a question. Why haven't you subscribed to this channel yet? Well, you can fix that right now. Just click here. Oh, you have? Oh, that's great. Be sure to also turn on notifications. Thanks. Scientists essentially never stopped asking why. But now with resources behind them, assuming they can get funding, they can start unlocking these secrets. Why? Because we want to know how the world works. We all do. Before the invention of science, we would make up stories to explain the world around us. Myths, legends, religion. But now, with the scientific process, we're finding out objective truths of the universe. The next step in the scientific process is to make a smart guess based on your experience. Premium fuel will give me 10% better efficiency because it burns cleaner. That's your testable prediction, your hypothesis. Fancy word, but it essentially is the thing you are testing. It's really important to state this clearly so you don't get off track when diving into the details. Now, time for the experiment. Here's what we're going to do. 1. Fill up your car with regular fuel. 2. Drive a good distance. And 3. Record how far you went and how much gas was used. You then repeat all of these 3 with premium fuel. To make it fair, you control other factors. Same driver, same speed, same tire pressure. That's called controlling variables, like a real scientist. If you change more than one thing at the same time, you won't know which factor is responsible. Ideally, you want to run the exact same long test course of 100 to 200 miles so that we get a really good sampling. However, we have stuff to do, so that's impractical. As long as we make accurate measurements of distance and gas used, it will work. We want to know miles per gallon for the entire test, so we need to record miles of driving and gallons of gas for both fuel types. Total miles is easy. It's just the difference in the odometer readings, final minus initial. But how much gas exactly you use is trickier because you don't want to empty the tank completely. Start by filling the tank. Do the test until there's about a quarter of a tank left. Then fill up again and make a note of how much gas you purchased. That's how much you use for the experiment. Measure full to full. Now you can run the second part of the experiment with the other type of fuel. Then immediately go fill up to find out how much gas you used for the second run. Experimenter bias is an aspect that needs to be considered in this step. When collecting data, you must be impartial. In other words, you need to be open-minded to the conclusion. Don't prejudge. If you're measuring distances or elapsed time in an experiment, that's easy. But if you're test driving a car for gas mileage, you may want the premium gas to be better, so you could drive more conservatively with the premium tank and punch the accelerator at every green light with regular. A great example is the famous math horse Clever Hans. He was a German horse who lived from 1895 to 1916 that seemed to do arithmetic and calendar calculations. He was a sensation. For example, his proud owner would ask him, "What is 2 plus 3?" Hans would confidently tap his foot 5 times. He could do multiplication, division, and even fractions. Amazing! Well, not really. It turns out his trainer, Wilhelm von Osten, the only one who asked the questions, was giving him visual clues when to stop tapping his foot. Now you analyze the fun part. Total mileage divided by total gas used. For the regular fuel trip, 160 miles using 6.4 gallons, that's 25 miles per gallon. And for premium, 180 miles with 6.54 gallons, so that comes out to 27.5 miles per gallon. Our conclusion, there is indeed an increased performance for premium of 10% better mileage. So your data supports your hypothesis. You were right! But what if your hypothesis is wrong? Maybe there is no difference in gas mileage. Well, in that case, you've learned something. And it's back to the drawing board with a new observation. Premium gas rides seem smoother with less engine noise. The new question, does premium fuel significantly lower engine knocking? So we could revise our hypothesis to premium gas reduces engine knocking by 25%. By the way, that's pre-combustion or backfiring, creating a knocking noise in your engine. You can now design an experiment to test it, maybe mount a microphone under the hood, collect new data with the 2 types of fuel, and then reanalyze the results. Scientists do a lot of this kind of looping. It's a great way to learn about the world. So that's the heart of the scientific process, data-driven conclusions. But we're not quite done. Step 7 is to publish results. Scientists share results in science journals like Science, Nature, and the Proceedings of the National Academy of Sciences. This allows for fellow scientists to provide feedback. Is there another explanation? Can others duplicate the results? If the science is real, others will be able to run the same experiment with a similar outcome. In your case, you might tell friends at a car forum or post about it online. That's communicating your findings. The final step in the scientific process is peer review. One experiment or study is not enough. Before an idea is accepted by the community, it needs independent validation. More data. Ask a science-friendly car enthusiast to do the same experiment with their car and compare results. In the science community, getting a skeptic to replicate your work is the best candidate because if they get similar results, that will go a long way to getting peer acceptance. So why does this matter? The scientific process isn't just for labs, it's how we make smart choices. Whether you're tweaking your workout, adjusting your budget, or testing the best way to grill burgers, you're a scientist whenever you follow these steps. Next time you have a problem or question, think like a scientist. Break it down, test it out, and make decisions based on real data. Do you know who came up with the scientific process? Find out in this video.